This video, we're going to prove the following fact. If H is a subgroup of G and N of H is defined to be the set of all little g's in G such that gHg inverse is equal to H, then N of H is a subgroup of G. If you like watching mathematical proofs like the one I'm about to give, then you should seriously consider subscribing to my channel, as this is what we do here. We prove math theorems. So let's get into this proof. So to show that something's a subgroup of a group G, we need to show that N of H is closed and that it contains its inverses. So let X and Y be in N of H. Well, that implies that XH X inverse is equal to H, and Y times H times Y inverse is equal to H. So the question is, does this equal to H? Well, this is the same as XY times H times Y inverse X inverse, but that's the same using the associative property as this, but that's Y. Sorry, that's H because Y is in N of H. So this is equal to X times H times X inverse, which is equal to XH X inverse, which is equal to H because X is an element of H. So I showed that XY is in N of H. That is, we have closure. Now we need to show that there exist inverses. So let X be in N of H. Well, that implies that XH X inverse is equal to H. Now, I'm going to multiply on both sides by X inverse and on the other side by X. The right side is X inverse H times X, which is the same as X inverse inverse. And the left side, using the associative law, is X inverse X times H times X inverse X. This is EHE, but that's HE, which is H. H is equal to X inverse X times X inverse inverse. Let's just formally have this down. But this implies that X inverse is in N of H, because that element times H times that element inverse equals H. This implies that, therefore, N of H is a subgroup of G. If you're into watching mathematical proofs like this, subscribe to my channel. Please click the like button. Definitely leave a comment. Tell your friends and enemies and family members about my channel. See you folks in the next video. Never ever forget. Keep watching, learning.